everyone. Myself Prayak Patel, working as an assistant professor in IT ICT department of LJ Institute of Engineering and Technology. Now in today's video lecture, I will discuss about the algorithms of greedy technique. In unit number 5, greedy algorithm, we discuss here different algorithms. Now here outline of today's video lecture, 3 algorithm I will discuss. First one is algorithm for fractional knapsack problem, second one is algorithm of job scheduling, and third one is algorithm of activity selection problem. Now I will explain one by one algorithm. First consider the algorithm of fractional knapsack problem. Now using greedy algorithm we solve the fractional knapsack problem. We already discussed the algorithm example of this method in our previous video lecture. Now consider the algorithm for the fractional knapsack problem using greedy technique. Now first line, consider the argument in a given algorithm. Name of the algorithm, greedy fractional knapsack W1 to n. Means here consider the small w as a weight of the 1 to n object. So here consider, for example, 3 object x1, x2 and x3 object are there. Then weight of that object consider as a w1, w2 and w3 respectively. So now consider the next argument as a p1 to n. Now what is the p? P means profit. So here consider the p1, p2, p3 up to pn as a profit. Now last argument in a given algorithm name as a capital W. Now what is the meaning of capital W? Capital W means capacity of knapsack problem. So here you have a weight and value or profit for each and every object, and capacity of knapsack capital W are there. Now in algorithm consider the first line for I equal to 1 to n 2, means from starting from I equal to 1 and ending to n. Now what is the value of n? N means number of object, consider as a n. So in this example consider n equal to 3. Now here consider if 3 objects are there, then consider xi equal to 0 for I equal to 1 to I equal to n. Means here consider 3 object, means consider n equal to 3. So xi equal to 0. What is the meaning of x? X means selected object. So here consider x, initially no any object are selected. So consider initial value of xi equal to 0 for each and every position. So here 3 object. So consider here 3 step, 1, 2 and 3. x1 equal to 0, x2 equal to 0 and x3 equal to 0. Means no any object are selected. After that consider the next line. Here consider xi equal to 0. Now here consider what is the meaning of xi. We already discussed, selected object equal to 0. Now next step is weight equal to 0. Now what is the weight variable? Here consider weight as a one variable which define the selected object total weight. Means total weight of selected object. Now till now no any object are selected, so total weight equal to 0. Now consider the capital W, means given capacity of knapsack equal to 8 and total weight initially consider as a 0. Now compare the next condition, while weight less than capital W do, means you can select the object one by one until the weight less than capital W. Now initially weight equal to 0 and capital W equal to 8. So here consider weight less than capital W condition is satisfied. So you can perform the next line of this while loop. So consider the first line of while loop as a I equal to the best remaining object. Now you have a 3 object x1, x2 and x3. Out of these 3 objects consider the best object. Here consider the remaining best object. Already we have 3 objects, no any object are selected. So here consider the remaining object as a x1, x2 and x3. Now best remaining object means here first we find the value of pi upon wi. So out of these 3 value consider the best value pi upon wi as a 5. So here consider first object x1 is selected. So I consider as a x1. So I equal to the best remaining object. Now here consider the selected object as a x1. Now next condition is if weight plus Wi less or equal to capital W, then perform the next operation. Now weight means initially 0, Wi means weight of the selected object, and here selected object as a x1, so weight of the x1 equal to 2. See in this table. So here consider 0 plus 2 equal to 2, 2 less or equal to capital W. Yes, then what can do? Here consider the select the object number 1. So here we represent the xi equal to 1. See in this step xi equal to 1. What is the meaning of xi? Xi means selected object. Object is selected, then xi equal to 1. Object is not selected, then xi equal to 0. So initially we have value of xi equal to 0 for 1, 2 and 3. But now we select the object 1. So here consider the xi equal to 1 means x1 equal to 1 because we select the first object. Now consider the next step, weight equal to weight plus Wi. Now already weight equal to 0. But after the selecting first object, what is the weight? Weight means weight, old weight equal to 0, and Wi means weight of 1 equal to 2. So weight equal to 2. According to this step, we can perform the each and every object selection operation until the our condition while weight less than W is satisfied. So here consider if condition. Now after the false of this if condition, we can compare the else part. Now what is the else part? Here we consider first we select the object number 1, then we select the object number 3 because object number 3 ratio equal to 3. So next time we select the object number 3. After that selected object weight equal to 2 plus 5 equal to 7 and capacity of knapsack equal to 8. So while condition is satisfied, but in if condition weight plus Wi less or equal to W condition is not satisfied because weight equal to 7 plus Wi equal to 3 for object number 2. So for object number 2, if condition is not satisfied, that's why we consider the else part. In else part, consider xi equal to W minus weight. Now what is the value of W? W means 8 minus weight. Weight means 7 because we already select the object number 1 and object number 3. So 5 plus 2 equal to 7. So W 8 minus 7 equal to 1. Divide by Wi. Now what is the value of I? I means now we discuss about the step number 2 means x2 second object. So consider the W2 and weight of 2 equal to 3. So here consider 1 by 3. So here we write in this sequence x equal to 1, 1 by 3, 1 because 1 and third object is selected and second object selected but not complete object selected. Here consider the fractional part means out of the 3 kg we select only 1 kg. So here write the 1 by 3 option, and next step is weight equal to capital W because we select the 1 kg already total equal to 7 kg and we select 1 kg means total equal to 8 kg. And last step return x means value of the x selected object consider as a x equal to 1, 1 by 3, 1. Here consider this is a final answer for fractional knapsack problem using greedy algorithm. So this is considered as a algorithm for the fractional knapsack problem. Now what is the time complexity of fractional knapsack problem? Consider the time complexity equal to big O of n log n. Now consider the another algorithm using the greedy method. Second one is algorithm of job scheduling. Here consider the second algorithm for a job scheduling. Now consider one example of the job scheduling. Here we have a different job deadline and profit are given for each and every job. Now consider the algorithm. Now name of the algorithm consider as a greedy job scheduling. Here in this algorithm consider the deadline for each and every job and profit for each and every job. Now consider the what is the meaning of D, what is the meaning of J, what is the meaning of N. First D is deadline vector means here consider 1 3 3 1 3 1 3 1 as a deadline. Now out of this all deadline consider the maximum deadline for our solution. So consider 3 as a maximum deadline. Now what is the meaning of J? J is an output vector of selected jobs means after selecting the n job we consider the output vector as a capital J. Now consider the first step, J equal to 1. Here remember that in this case, here we consider deadline and profit, but we first arrange this given job into the profit according to decreasing order of profit. Means first consider maximum profit, then next profit, then next profit, like this. If given data are not sorted, then first we sort this data according to decreasing order of profit. Then we perform this algorithm. Now first one is J equal to 1, means initially we select the first job, means best job. Always we select the best job, means consider as a job number 1. Now for the next job, means from the job number 2 to job number n, here consider value of n as a number of jobs. So here consider from job number 2 to job number n, we perform the operation. For example, here consider this 1, 2, 3 location consider as a deadline, because maximum deadline equal to 3. So here consider 1, 2, 3 as a our slot. Now this part consider as a J. Now first we put the J1, for example, next put J2, then next put J4, like this. Now consider from I equal to 2 to n. What we can do here, consider first we check if all jobs in J union I can be completed by their deadline, then we perform the following task. Means here consider we select the one by one job. If first we select the first job, after that we select the next job, and for the next job, means job number 2, job number 3, job number 4, we check the condition J union I can be completed by their deadline. Means we select the job 1, then we select the job 2, then we select the job 3. If the condition is satisfied, means complete the job according to deadline, then we select this job. Now consider if the condition is satisfied, then we select J equal to J union I, means already J consider as a first job, then union I means consider as a second job 1 and 2. Next consider 1, 2 and 3, like this. After that consider the final algorithm is this. Now here consider the selected job equal to J1, J2, J4. Now how we can select this job? Here for example consider the first slot, second slot and third slot. First we select the first job because maximum profit are there. Deadline of first job equal to 1. So we select the first job at location 1. Put the job 1 at location 1. Now after that consider the job number 2. In job number 2 consider the deadline equal to 3. So consider the next as a job number 2, then job number 3, like this. Now what is the complexity of this algorithm? Now complexity of this algorithm consider as a big O of n square. Now consider the next algorithm. Third algorithm of this greedy technique is considered as a algorithm of activity selection problem. Now discuss the algorithm of the activity selection problem. Here consider the given set of activities. For example, 4 activities are there, A1, A2, A3, A4. Starting time and finishing time of each and every job is here. Now consider the starting and finishing time of each and every job. Greedy algorithm for selecting or activity selection problem. Consider first argument as a SF. What is the meaning of S and F? S means the starting time, F means finishing time. Here S and F containing the starting and finishing time of all activities. Now consider the algorithm. N equal to S dot length. Here N means consider S dot length means here how many number of activities are there, consider as a N. Initially N to the number of activity. Now consider A equal to A1 means here we select the first activity by default because the given data is in ascending order of finishing time. If the given data is not in ascending order of finishing time or increasing order of finishing time, then you arrange this data into the increasing order of finishing time Fi. So here consider the finishing time as a 3, 4, 5, 7 means increasing order. So consider the first object or first activity out of this all. So consider the first, select the first activity means activity number 1 A1. So A means selected object set. So A equal to A1. Now for K equal to 1, consider K equal to 1 initially because selected object variable considered as a k. So here we select the first object, so consider k equal to 1. Now first activity starting time equal to 1 and finishing time equal to 3, so consider 1 to 3 as a first activity. Now for m equal to 2 to n, means from second object to last object, consider the m. So m equal to 2 to n, here consider n equal to 4. So this loop execute from 2 to n. Now consider the next step. In next step, if starting time of the current activity is greater than recently selected activity in A, is called the condition. So here check the starting time of current activity with the previously selected activity's finishing time. So here consider condition as a if s of m greater or equal to f of k. S of m means current activity starting time and f of k means previously selected activities finishing time. So here check if s of m greater or equal to f of k, then we select this activity, means a equal to a union am. So here consider the second activity as a, for example, 2, then we select this activity. We discuss this example after the completion of algorithm. Now a equal to a union a of m, and what is the value of k? K equal to m, because we select the m number of activities. So here consider k equal to m. Now after that we consider the last step of algorithm is return a, means selected object group or set consider as a. So return a, return the set of compatible activities which can be solved. So here consider this example. First we select the first activity as a a1, then consider the next activity. Which one is the next activity? A2. Now what is the time of A2? Starting time and finishing time. Starting time of A2 equal to 3 and finishing time equal to 4. But we compare the starting time of current activity with the finishing time of previously selected activity, means previously selected activity equal to A1, finishing time of A1 equal to 3. So compare 3 greater or equal to 3, condition is satisfied, then we select the second object A2. Now consider the next activity A3. In activity A3, starting time equal to 2 and finishing time equal to 5. Now check last selected activity equal to A2 and next activity is a A3. So starting time of A3 equal to 2 greater or equal to finishing time of previously selected, means 2 greater or equal to starting time finishing time of A2. So here consider as a 4. So 2 greater than or equal to 4, condition is not satisfied. So not select this activity A3. Now check for next activity. For A4, select the A4 activity from 4 to 7. So here consider this activity A4 from location 4 to location 7. So this is called the activity selection problem algorithm. So in this case we select the 3 activity A1, A2 and A4. Now what is the complexity of this algorithm? Here consider the complexity of this algorithm in 2 cases. Which 2 cases? Consider first case as a we select the activity in a sequential order, means given data is not sorted, then complexity equal to n log, and the given data is sorted, then complexity consider as a big O of n. So consider this 2 complexity as a complexity of activity selection problem. Thank you for watching this video.